So I've got a summary of probability rules for you here. Those could be good to add to your notes. My big takeaway is make the table. I think that's going to make your life easier. And then we just have a couple special cases. So there's something known as a disjoint set of events. So events can be disjoint if they could never happen at the same time. So drawing a card that's red that is also a club, that's a disjoint event because clubs are black cards. You could never have both of those things happen at the same time. But you could draw a card that is red and draw a card that's a heart at the same time because hearts are a red card. And so I've written here all the time. So this is true no matter what. This probability rule. So the probability of A or B is the probability of A plus the probability of B minus the probability of both of them together. But if the events are disjoint, the chances of both things happening at once are 0. And so we can just drop that term off and we can simplify. The other special case are independent events. So events are independent if knowing that one happened doesn't give you any information about whether or not the other one happened. So if I get a heads on a coin flip, that doesn't give you any information about whether you're going to draw a red card from a deck of cards. But if I know that it's raining, that does give me some information about the chance of someone getting in a car accident. So the chance of getting in a car accident and the fact that it rained, they are not independent. Knowing that one happened would give you some information about the other. And the same way I've written all the time, so this equation always works. The probability of A and B is the probability of A times the probability of B given A. But if the events are independent, the probability of B given A is just the probability of B. Knowing A doesn't give you any extra information. And then we can simplify that the probability of A and B is just the probability of A times the probability of B. And so people sometimes use this to check if events are independent. If they know the probability of A and B occurring, they'll find the probability of A and the probability of B and multiply them, and then check to see if those two things are equal. But again, with these special cases, it's always okay to use the equation that always works. The reduced form is only going to work if that special case is true.